We could design the road borders now like this, but it kind of looks like a child made them. Making sure road borders have the same thickness everywhere is important and not fun. So today I'll teach you how to use geometry to wrap the graph segments in what I'm going to call envelopes. They're just polygons with more points here to make them look round. We then compute the union of these polygons to keep just the outer segments. This solution keeps the number of clicks to a minimum and makes the world building very satisfying, I think. Now, let's get this show on the road. Get it? Because we're gonna generate roads and no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
I'm gonna draw a simple graph that kind of looks like the letter J. Save it. And now let's implement the functionality that creates a polygon using these points. We're gonna test this functionality here after displaying the graph editor, like so, creating a new polygon with the graph points and drawing it on the context. So we need to implement a polygon and give it a draw method, same as the other primitives. Speaking of which, the polygon is also going to be a primitive here. And let's create the file, polygon.js. Now, the polygon is also a simple class, and in the constructor, I'm going to pass the points and store them as an attribute, like so. And the draw method, I'm going to give it the context and some options with the default stroke set to blue and the line width of 2. And I want it to be transparent. Let's set it to a transparent blue fill style, like this. Now, inside of the draw method, we begin the path. We set the fill style to the fill attribute, the stroke style to the stroke, and the line width to the line width. Now we move to the first point like this. And use a for loop to essentially create lines to all the other points one by one until we've connected all of them. So ctx line to points of I, x, and points of I of y, like this. And now we close the path. This will draw the line back to the first point. And then I want to fill and also stroke this time. Let's save and refresh the page. And now we get this. So the graph is still there, but now we also see this polygon, this blue polygon on top of the graph points. And if I'm going to add some more points here and play a little bit with these points, maybe connect these ones, you can see the graph starts to appear here in the middle. But the polygon and the graph are two different things. It's not the same kind of structure. The graph can have these branching elements here. Now, the next thing I want to do is create a polygon along one of these graph segments. So somehow enveloping it in a polygon. And we're going to do that by creating another object called envelope. And it's going to be used like this. New envelope, graph segments of 0, the first segment, and let's give this a width, and the width of 80 pixels, and draw it on the context, like so. As before, we define here another primitive envelope in our envelope JS. Class envelope, and the constructor is going to take the parameter, the segment, and I'm going to refer to this as skeleton. It's like the inside of the envelope. And the second parameter is going to be the width of this envelope. Let's store this skeleton as an attribute, and we'll use the width to generate the polygon, like so, in a private method called generate polygon, like this. Now we're going to be working with the points of this skeleton, and I don't want to type this skeleton P1, this skeleton P2 all the time, so I'll just use the destructuring assignment like this. And now we can just use P1 and P2. We also need the radius, half of the width, and the angle between P1 and P2, we can get it with arctangent 2 method between the difference of those points, like that. Now, we're going to need an angle that is offset by 90 degrees, and actually offset 90 degrees clockwise and counterclockwise. So I'm going to refer to that angle like this, and just add half pi to alpha, and let's copy this below and say here alpha counterclockwise, and put a minus here for minus 90 degrees. And now we can start to get points that are offset. So from P1, we are going to get a point P1 CCW, offset counterclockwise, by translating P1 according to alpha CCW by the radius. This is going to be the offset that we move it along the angle from this given point, P1. We're going to need to implement this translate method, but I'm just going to first use it here to define the other similar points. P2 CCW coming from P2, and then P2 CW coming from P2 and alpha CW, and P1 CW coming from P1 alpha CW, like this. And these are the points that we will use to create our polygon. So we return a new polygon with this array of points, like so. Let's implement this translate method, and maybe we'll also extract this angle function, because this is kind of cryptic here. Like, if you don't know the formula, what is this doing? So inside of math and utils, I'm going to go here at the bottom and implement our translate method. Which returns a new point relative to the given location. We add, and now we have to use the trigonometric circle, and remember that on the x it's the cosine of the angle, and we multiplied this cosine by the offset, how much we want to move it, because cosine is between 0 and 1, so multiplying this is going to move the point a total of offset on x and y respectively, so diagonally. Now that angle function is going to be really easy. Given a point, we just output its angle. Like this. And back here, we can replace this with angle, and then we can just subtract the 2 points because that's what this is doing. So let's put here angle, subtract P1, P2. And to draw the envelope, we also need to give it a draw method here. And for now, this is just going to tell the polygon to draw itself. Now save this and refresh, and we get this. You can see now this polygon forming surrounding only the first segment of the graph. The others are ignored for now. But I want this polygon to have curved sides like that here surrounding this, because round roads are just nicer. So let's figure out how to do that here. I'm going to first collect some points around P1. I do that by defining here an array called points. And now let's loop from alpha counterclockwise to alpha clockwise and increase this I with a step. We'll define that in a second. And then push into these points, translating P1 at this I angle by the radius. And this step is going to be a fraction of pi, actually. I like to use pi when dealing with circles. And let's try to see what these points look like. So I'm going to pass here points instead, and we really don't need these other variables. They were just there to learn how this works. Save and refresh. And now we get this. We get some kind of curviness here. We can actually control this by this value. If we put here 10, for example, we're going to get a much more curvy shape. And let's do the same thing with P2 as well. So I'm going to copy this below. And this doesn't change, but here we are going to use P2. And it's on the opposite side, so 180 degrees difference. And I'm going to add here mat pi plus I like this, and save, refresh, and now we get this. This is actually a parameter, how round we want this shape to be. And we could replace this with roundness. And here, let's pass it as a parameter, roundness. And I'm going to pass it also here and here, maybe give it a default value of something. Let's try what happens with 0, like 0 roundness. This doesn't really look good. Let's try 1. It's what we had previously, and this is actually what I would assume to have if the roundness is 0 as well. So I'm going to go here and do this kind of trickery to avoid that 0 situation, because it doesn't make any sense. And now when we set 0 here, it's actually going to look like 1. Oh. When moving it like this, there seems to be some problem. And it happens because here, sometimes I doesn't exactly reach alpha underscore CW. This happens because how floating point numbers work. And sometimes you just get a value that is below that. And the next value adding step exceeds that. So it never hits exactly there, and then you're far from this end result. We can fix this by adding a small epsilon value, and I'm making it here a fraction of the step. We add this epsilon value here to this, and in that way we guarantee that we include this final angle there, and we don't go overboard because it's just half a step in this case. So I'm going to save this, refresh, and now no more strange artifacts like that coming. I'm going to keep this default roundness here to 1 because it somehow makes sense. You can create an envelope without a roundness, and we can play with the parameters here as well if we want. Maybe set a width of 200 and let's give it a roundness of 20, see how it looks like. Okay, really round, large shape there. Now, I really want to generate these envelopes for everything, and it's time to start thinking about defining our world object, the one that will contain the roads and all the other components there, because these envelopes are going to be part of what is required to build that world. So let's implement this world object containing all the things, and in there have a way to generate all the envelopes for all the graph segments. I'm going to go here below this graph definition and instantiate the world with the graph. The world will be based on this graph. And now I want this world to automatically update every time we change some things, every time we edit the graph. And I'm going to add this call here to generate the world and also to draw the world. And I'm doing it before the graph editor because it's going to contain things and I want to still see the editing tools on top of that. Let's now import a new file called world.js, and this is going to be here in the root.js directory, so next to the editor and the viewport. And the class is going to be also relatively simple for now. It's going to become quite complex by the end of this course. I'm going to pass here some default parameters like the road width and roundness. And let's store these things as attributes as well. And the roundness. And now I want to store these envelopes, to generate these envelopes. We will generate them in this class attribute, which is empty by default. And the generation will happen here. We generate them with this generate method. And if they're already generated, because we do this in a loop, in the animation loop, we empty this array to begin with, because we are going to regenerate them again and again on each frame. Maybe we change the editor and then we want the changes to reflect in the world that we create. So let's loop through all the segments now. Like this, and push into this envelopes array a new envelope from this seg, and with the road width and road roundness attributes from above. And now this world is also going to need a draw method. And I am just going to, for now, loop through all of these envelopes and draw them on the context one by one. Let's refresh. And now we get this. It's funny to play with this. Reminds me a little bit of this co-op game I made in a live stream once. All right. Now, the thing we need to deal with next are these sections here, these kind of intersections between these envelopes. They need to somehow disappear, and all of these envelopes should form a union, a single shape that doesn't have any kind of overlapping parts. The first step in that is actually detecting these intersecting points, all these small intersecting points between the envelopes. And we are going to do that for the first two envelopes to begin with. Maybe I remove this part from here and save a simpler version of the graph to avoid confusion. So let's find all these intersecting points here somehow. We'll store these intersections here in an attribute. And the function that will do this is called break. It's going to be a static method inside of the Polygon class, and it's going to take two polygons and break them. You'll see what that means soon enough, but it will return these intersections that I was talking about. So here we are going to draw also these intersections after the envelopes. Maybe int, and this intersections here. And they will appear on the canvas after we implement this break method. Let's go to Polygon.js, and it would be useful to have the segments of this polygon as well, the sides of the polygon. Having them readily available here is going to make implementing the break function easier. So in the constructor, I will also get the segments by looping, starting at 1 through all the points like this, and pushing into the segments array a new segment between the previous point and the current point. And I want this to loop. So when I is going to be equal to points.length, then points of I would return an error. But doing this is going to return the remainder when dividing by that. So this will jump to 0 instead of giving an error. And that's going to loop around and connect back to the first point, which is what we want to have that segment as well. And now we can implement that static method called break that takes two polys, poly1 and poly2, and really only uses the segments of those. So let me just take poly1 segments and poly2 segments like this, and now define the intersections that we want to find, and find them by looping through all the segments of the first polygon. And for each segment, we check to see if it intersects any segment of the second polygon. So we need this other for loop here as well. And then we get the intersection between P1, P2 of the first segment and P1, P2 of the second segment. And then we check here if the intersection exists, because sometimes segments don't intersect, and if the offset is different from 1 and different from 0. This means that they don't intersect exactly at the tip, which is a situation we want to avoid. Then we get the point from this intersection object. You'll see that in a second. And push to the intersections this point. And then return intersections like this. Now I'm going to go to utils.js and add this getIntersection function. And I'm just going to go down here and paste. So this function I'm not going to explain. I already have a special video about it, and it was part of phase 1 of the self-driving car course. So if you took phase 1, then you already know what this is. It also includes this linear interpolation function, which I also have a video about, and we also used in phase 1. I will link to this code somewhere in the description, so you can copy it now. But well, let's see if it works. And it does show some points here. Let's make them a little different looking so we don't confuse them with the graph points. So here, when we draw the intersection, I'm going to say color it red and make it smaller. I think the red color is enough striking. And now we get this. Yep. Seems like it works. And what we'll do next is we're not done with this break method here. It doesn't just create the intersections, but it's also going to break these segments so that, for example, this segment here on the side of this envelope is going to be divided into this segment and this segment. After that, we're going to take the segments that are contained inside of another envelope and remove them. That's how we're going to do the cleaning. So let's do this breaking at this intersection point. Here, after we have this intersection point, I'm going to keep a reference to P2 of segment 1 and replace P2 of segment 1 with this. So what we did now is, instead of having this large segment, we just replaced the endpoint to be here. This space here is empty. And we need to create a new segment that starts now here and ends at that place. That's why we kept the reference to the original P2. We need to use it now. And we do that by using splice at i+1, so the next segment, and we don't remove anything. Splice expects here how many things to remove from the array. We don't want to remove anything. We want to add a new segment starting at the intersection and until what was P2 previously. And we do this also for the other segment where the intersection happened. So I'm going to copy this without this let, because I just want to reassign this auxiliary variable to something else. And this is going to be segs2 of j and segs2 of j, segs2 splice at j+1. And this should work, but we need a good way to test this. And I'm going to do that here. I will implement a way to draw the segments by using different colors. And in that way, we know if it's the same segment that continues after the intersection point or something else. So going through all the segments, I will draw them on the context with the color getRandomColor. And this, let's go to utils. Again, I'm going to paste something. Again, we used it in phase 1 to draw cars in different colors. Let's also go to envelope.js here. And after we draw the poly normally, I'm also going to draw segments with this debugging function we just implemented. So refresh, and now we get this crazy thing with a lot of colors going around. Let's make these segments wider. I think they are not very visible as such. So I'm going to pass here inside of the Polygon.js draw segments also width of 5. Now refresh looks a little better. I'm actually going to remove the intersections. We don't need them anymore. We know they work. And actually, this break function doesn't need to collect and return the intersections. It just needs to break the polygons. So I'm going to remove this part from here as well. It uses the getIntersection function, but it doesn't collect the points. We don't need that. And inside of world.js, I'm going to stop using the intersections there. Refresh. And things move a lot, but you can kind of tell that this color here is not the same as this color here. And here there are quite many small changes as well. You can debug this better by typing debugger in the console, and this is going to instantaneously stop what is happening here. And you can see this green, red, orange, and pinkish color here, and a lot of these small changes here every time something intersects. So the code seems to work, but only for the first 2 envelopes. If I'm going to draw here another one, you can see this segment here is not affected. This segment here is not affected. And same for the small ones here. So this is the difference, what we did now, breaking the polygon segments at the intersection points, contrary to what we have on the right. And what we're going to do next is do the same thing on the right and for every possible combination of envelopes. Instead of having here polygon break, we are going to remove this line and have polygon multi-break. And I will take all the polys from all the envelopes and send as a parameter, one array. Now this multi-break inside of Polygon.js, let's add it here at the top, is a static method that gets this array of polys. And I'm just going to loop through the polys, excluding the last one. And then for each of these polys, loop again, starting at i+1. So I'm not going to compare polys twice. I'm just going to compare every poly with all that follow afterwards. And that means we don't do unnecessary work. And this one will go all the way until the end. And now we use the previous method break between polys of I and polys of j, like this. And if we save and refresh, let's add again this other segment here and call here debugger. We can see now that this intersection is breaking everywhere, as it should. And what we'll do next is calculate a union of all the segments that are not inside some other envelope. So this segment will disappear, this will disappear, this will disappear, this small one here will disappear. These ones will disappear because they're in this envelope, and these will disappear because they're also in this envelope. These disappear because they're in this envelope. So everything that is inside some envelope will disappear. And the result from this will just be a set of segments that we keep. It will not be a polygon anymore. Because, for example, the resulting shape here would actually be a polygon. It would start like this and go like this around and then have a concavity here. But if you think about this shape here, it would be a polygon that also has a hole, and that's a more complex structure, and I don't want to get into that. So let's implement our union function. Maybe we save this graph as well. And here we start off this union process with the given polys with a multi-break. So we break them to get the individual segments. And now let's collect the segments that we wish to keep in this array. I'm going to scroll down because this is going to be a longer function. So looping through all of the polys one by one. And now looping through all of the segments of a given poly. We have to figure out if we keep this segment or not. So I'm going to say keep is true for now. But if this segment is inside another envelope, another polygon here, then we don't keep it. So let's loop through the polys again, through all of them, but ignore here the situation when I is equal to j. So we don't want to check if a segment is inside of its polygon. It makes no sense. And in that case, when it's different, then we check if it does contain this segment. If one of these polys contains this segment, this seg right here, then we don't keep it anymore. We say keep is false, and we can break here to save some computational time because it could be inside several envelopes. And here, if we keep, then I'm going to push it to the kept segments like so. And at the end here, we return these kept segments. So it's a longish function, but it is what it is. I'm not going to refactor it anymore. What we need to do next is implement this contains segment function. So how do we check if this segment is inside something else? And because these segments that are inside are entirely inside something else, I'm going to simplify this and only work with the middle point of the segment. So the average of the endpoint locations here. What that means is that this contains segment is going to transfer its functionality to another method called contains point, which is a simpler thing to do. Now, this is not really a great implementation because sometimes the segment may be just partially inside, but for our needs, it's going to be okay. The only problem is the name of this method right here, contains segment, is a little bit misleading because it only checks if the midpoint is contained inside it. And the average function here, it's just a simple thing that we add quickly here in utils. Let's move it next to the other point vector operations. So average of 2 points. I'm just going to return here new point p1x plus p2x divided by 2 and p1y plus p2y divided by 2, like this. And now we can go back and implement the contains point algorithm. For this, we're going to need an outer point. That outer point, I'm just going to define as a point that is far away in the top left, maybe minus 1000, minus 1000. I just hope nobody goes there and draws the graph in that area. It's going to make some small glitches happen, I guess. And then what we're going to do is we're going to check how many times this line segment from point to this outer point intersects the polygon. If it intersects one time, then it means that we are inside. But polygons can be quite complex shapes. Sometimes this line segment may cross it multiple times. Maybe it goes outside and then inside again, and then outside again. But if it's always going to be an odd number of times, then that means that we are still inside the polygon. If it's an even number of times, it means we're outside of the polygon. We just crossed it to go in and then out. Then we reach this outer point, an even number of intersections. So that's how the algorithm is going to go. I'm going to define here intersection count, set it to 0, and go through all the segments of this polygon and calculate the number of intersections from outer point to P1 and P2 of this segment. And if there is this intersection, I'm going to increase the intersection count like this. And at the end, we just return if the intersection count, if the remainder when dividing by 2 is 0, then this doesn't contain the point because it's even. But if it's 1, then this does contain the point. So we are done with our method now. To test, we need to assign these new segments to some object here. And I'm going to call this road borders, like so. And here we are going to say road borders is equal to Polygon Union of all the polys. And in the draw method, I'm going to loop through all of the segments of this road borders and draw them on the context. Maybe we give them some clearer style here. Let's give a white color and a width of 4, so the line is thicker. Let's save, refresh, and now you can see here these white sections are only on the outsides of the envelopes. Let's set larger roundness, maybe 10. And now you can see these white sections are here curving quite nicely around this shape. Let's style this to look more like a road. I'm going to make the envelopes gray. Let's remove also this crazy colorful highlighting there. So the envelopes here, I'm going to style them with the fill of BBB. So this is light gray, and the stroke is going to be also the same. This means we have to pass options to the envelope draw method as well, because it doesn't have them at the moment. So options, and let's pass these to the poly so that it's going to use the same options, and we don't need this draw segments anymore for the colorful highlighting. Refresh, and now it looks like this, and you can play around with it and see that it does behave quite nicely, as you would expect. But I would like to add a little bit more of a region here that is gray, so that this white border of the road is not exactly on the border of the road, but the road continues just a little bit. It's just a marking. To do that, I'm going to go back here and give also line width of maybe 15 to the envelopes. And now we see here this margin like that. And I would also like to draw the mid lines on the road as dashed lines. So for that, we're going to go here and loop through all of the segments of the graph and draw each segment also with white and also maybe 4 and a dash of 10, 10. Save, refresh, and something happens here, but this graph editor is blocking and I can't really see what is happening. Maybe we go to index.html and let's try commenting out this graph editor. Yeah, and graph editor actually still works even without displaying the things there. So you could leave it like this, but I don't like it. I don't get those intents marked in any way, like if I'm hovering something or what is going to happen when I click here. Aha, something weird happened. I didn't know that because I don't have my editor anymore. So I will remove this and I will just go here and add transparency for the editor. I think that this is going to be enough. So now I still see it, but it's not anymore the main thing there. The roads are more emphasized.